Lesson 23 practice problems. Okay, first question. This year, students in the ninth grade are collecting dimes and quarters for a school fundraiser. They are trying to collect more money than the students who were in the ninth grade last year. The students in ninth grade last year collected $143.88. Use D to represent the number of dimes collected and Q to represent the number of quarters. Which statement best represents the situation? So a little bit of kind of key information here is that they're trying to collect more than. So that tells us that this is going to be an inequality. So how am I going to write that equation? Let's go ahead and change the colors here. Dimes are, if you aren't sure, worth 10 cents. So we'll represent that with 0.10. Quarters are 0.25. And so all of the inequalities start with 0.25q plus 0.1d. So you just have to figure out which of those inequalities that you want to do. Oh, I'm sorry. Actually, they're being a little bit tricky here. You want to make sure that the q, which is the quarters, goes with the 0.25 and the d goes with the 0.1. So we can straight away eliminate c, and we can eliminate a, because those have the decimals in the wrong places with the wrong variables. And so the question says they're trying to collect more money. So that means not more and equal to, just more. And so that leaves us with D as our choice, because the greater than or equal to means you could actually get equal, and that's not what the question's asking. Question 2. A farmer is creating a budget for planting soybeans and wheat. Planting soybeans costs $200 acre and planting wheat costs $500 per acre. He wants to spend no more than $100,000 planting soybeans and wheat. So first of all, we have to specify what the variables represent. So we're going to go ahead and use S for the soybeans, and I'll say the acres of soybeans. If you didn't know, an acre is a measurement of land, and so that's just a way to kind of like square meters or something like that. And then the other one is wheat, so we'll use W for the acres of wheat. And the inequality is going to be, it costs 200 per acre for the wheat, so that's going to be 200 W, and it costs, I'm sorry, the 200 is for the soybeans, so that's going to be 200 S, plus it costs 500 per acre for the wheat, so that's 500 W, and he wants to spend no more than $100,000. So that means he's got to stay less than or equal to $100,000. So that would be the inequality for that first one. For B, name one solution to the inequality and explain what it represents in that situation. So really, any combination that stays below 100,000 is fine. So I could just pick, I don't know, let's pick 40 and 100. Okay, so 40 that is my is going to represent the acres of soybeans. I'll just use S. And the 100 is the acres of wheat. And you could go through and check that out. So if I took 200 times 40, that is going to give me 8,000. So that's the first part of my inequality, 200S. And then I'm going to do 500W. So 500 times W, which is 100. And that's going to be 50,000. And you can see if I was to then add those together, it gives me 58,000, which is less than 100,000. So that would be one possible solution. And of course, there's a bunch of solutions that could be right for question 2. Question 3. Elena is ordering dried chili peppers and corn husks for her cooking class. Chili peppers cost $16.95 per pound and corn husks cost $6.49 per pound. Elena spends less than $50 on D pounds of dried chili peppers and H pounds of corn husks. Here is the graph that represents the situation. First, write the inequality. So my variables are going to be D for the chili and H for the corn husks. So that's going to be, we know chili costs $16.95 per pound So 1695 D plus, it's 649 for the corn husks, so that's 649 H, and we know that it needs to be less than $50, so less than $50. You notice on the graph they're using a dashed line because it's a less than, and we don't want to include the actual points on that boundary line. Part B, can Elena purchase 2 pounds of dried chili peppers and 4 pounds of corn husks and spend less than $50? Well, we would take the 2 and we would substitute it in for D, and we would take the 4 and we would substitute it in for H and see if it works out. And the answer to that one is no, because that is not going to be less than 50. And I'm not going to do the calculations. But another way that you could express this without the way that we know that is it's not in the shaded region. So you don't even have to do any calculations, because if you just go up to the graph and find 2, 4, 2, 4 is going to be like right here. That's not in the shaded area, so we know that that combination is not going to be a solution. Part C says, can Elena purchase 1.5 pounds of dried chili peppers and 3 pounds of corn and spend less than 50? So let's just go right up to the graph. 1.5 and 3, that is going to be about right there. So the answer would be yes. And the reason it is in the shaded region. And if you had chosen to plug 1.5 and 3 into our inequality up here and show that it was less than 50, that'd be fine too. So you can either refer to the graph or use the inequality. Question 4, which inequality is represented by the graph shown? So on this one, if you look at these, I would probably come up with, well, let's see, what would be a good strategy here? There's different ways you can do this. What I'm going to do is I'm going to turn this, I'm going to find what the equation of that line is in slope-intercept form, okay? So it's going to be y equals, and then my slope, and you could, pick any 2 points on the line. Let's say I pick these 2 points. I'm going up 2 over 1. So my slope is 2. So it's going to be y equals 2x, and then the y-intercept is at minus 6. So I'm looking for which one of these expressions down here, okay, is going to be equivalent to y equals 2x minus 6. So you notice all of them, or the first two, are in the form 4x minus 2y. One is greater than 12 and one is less than 12. So I'm just going to write this as an equation to start and change that to, turn it to slope-intercept form and see if it equals y equals 2x minus 6. So I would add, no, I wouldn't do anything with the y. I'm going to leave that alone. I'm going to subtract 4x here. That gives me minus 2y equals minus 4x plus 12. Divide by negative 2. Those cancel each other out. And that's going to, when I divide, going to give me 2x minus 6, which if you see, these are now, those are two equivalent equations. So I know that my answer is going to be either A or B. The second two aren't going to work. 4x plus 2y equals 12 wouldn't give me y equals 2x minus 6. So then the question becomes, which one is it? Is it the greater than or the less than? I think what I'll do is, to figure that out, I'm going to pick my test point. I know that 0, 0 is a solution because it's in the shaded region. And so let's just take 0, 0 and plug it into A and B and see which one works. So for A, that's going to give me 4 times 0 minus 2 times 0. And I'm going to see, is that greater than 12? Well, this just equals 0 minus 0, or just 0. Is 0 greater than 12? No, 0 is smaller than 12. So that means A is not going to work, because 0, 0, we know according to the graph, 0, 0 is a solution. And you can see if you plugged it into the next one, that's still going to equal 0, and 0 is less than 12. So B is going to be my final answer. So a bunch of ways you could do that problem. That's just one possible strategy. Question 5, getting back into Unit 1. Here are some statistics for the number of minutes it took each of 9 members of the track team to run 1 mile. When a 10th time is added to the list, the standard deviation increases to 1.5. Is the 10th time likely an outlier? Okay, so on this one, the standard deviation was 1.1, and then it jumps up to 1.5. So that tells us that the data is going to be more spread out. So I would say that on this one, that's not that's increasing the standard deviation, but not by a large amount, like what's happened here. Tells us that that new value is probably, well, let's see. It probably is an outlier because that's a pretty big jump in our standard deviation. So I'm going to say it's probably an outlier. I'm not 100% sure without going through and doing that calculation, but because because of the increase in that standard deviation by that much, I would say it's probably going to be an outlier. I mean, I could go through and try a few values, but I'm just going to leave it at that. 6, Elena is solving this system of equations. She multiplied the second equation by 2 and then subtracts the resulting equation from the first. To her surprise, she gets 0 equals 0. What is special about this system of equations? Why does she get this result? What does it mean about the solutions? And if you're not sure, you can go through and try graphing them later. So on this one, you can see, like, if I do what they say and multiply that by 2, I get 10x minus, not 6 anymore, minus, minus 6y is equal to 16. These two equations are equal to each other, okay? And so what that tells us, sorry, misspelling there, those are equal to each other or equivalent. So what that tells us is that second equation is actually equivalent to the first. So I'm going to say equation 1 and 2 are equivalent. And thus, they have the same, I would say that the same solutions as each other. And if you went and tried doing the graph of this, these two equations, 10x minus 6y equals 16 and 5x minus 3y equals 8, it would be the same line because they have the same solutions. So there's going to be an infinite number of solutions to this system of equations. Question 7, Jada has a sleeping bag that is rated for 30 degrees. This means that if the temperature outside is at least 30 degrees, Jada will be able to stay warm in her sleeping bag. Write an inequality that represents the outdoor temperature at which Jada will be able to stay warm in her sleeping bag. I would probably say I'll use T for temperature, and T needs to be greater than or equal to 30 in order for her to stay warm. Write an inequality that represents the outdoor temperature at which a thicker or warmer sleeping bag would be needed. Well, that's when the temperature drops below 30. Okay, so just T is less than 30. Question 8, what is the solution set to this inequality? So here we're going to have to go through and do a little bit of algebra. That left side's already simplified as much as I can, so I'm just going to leave that. The second side, start by distributing the 3. And then I'm going to do a little bit of simplifying over there. Combining my x's gives me 3x. 6 minus 2 is 4. Now I need to get those variables on the same side. And then I need to isolate the x. So that leaves me with 3x is greater than 24, or x is greater than 8. So x is greater than 8 is my solution set. Question 9, you're given the graph of 2x minus 3y equals 15 there on the graph. Are the points 1.5, negative 4, and 4, negative 4 solutions to that equation? Well, we could plug them in and see. I could substitute these into that equation, but since you've already got the graph and the graph represents all the solutions, let's just use that. 1.5, negative 4 would be right there. That is on the line, so yes, that is a solution. 4, negative 4 is down here. That is not on the line, so that is not a solution. So explain or show how you know. Showing would be probably if I substituted into the original equation and show that it didn't equal. But what I did is I would probably explain, I looked to see which was on the line. And either way is fine. You just have to have some way to justify your answer. Claim evidence reasoning. Check if each of these points is a solution to the inequality 2x minus 3y is less than 15. So again, I could plug all of those in, or I could look at that graph. Now I graphed the line 2x minus 3y equals 15. So when I put a less than 15, well, that means that first of all, this should be a dotted line or a dashed line, because I don't want to include the points on that line. And then I need to figure out which side am I going to shade. Well, I would probably check the point 0, 0, plug that in. That would give me the statement 0 is less than 15, which is true. And so that tells me 0, 0 is a solution. And so if I was going to shade the side where my solutions are, it's going to be everything on the side that has the 0, 0 on it. So all of those are my solutions. So now I'm just going to go check. 0, negative 5. Okay? That is on the line. Okay? But remember, I don't want to include the points that are on the line when it's a less than or when it's a dashed line. So that is not an answer, a solution. 4, negative 2. I go over 4, down negative 2. That is in the shaded region, so that is a solution. 2, negative 4 is outside of the shaded region. It's on the other side of that line, so 2, negative 4 is not. 5, negative 1 would be right up there. That is in the shaded region, so that it is. So we've got 2 out of those 4 that are parts of the that are solutions. C, shade the solutions of the inequality. Ooh, I jumped ahead and did that already, so I already did C. And D, are the points on the line included in the solution region? So on the line, the answer would be no, they are not included. Explain how you know. Well, there's different ways you could do this. You could actually take 2x minus 3y is less than 15 and try one of the points that are on the line. Like the first one that I did there was 1.5, negative 4, because that was actually on the line. That was down here, right there. So if I plugged 1.5 in for x and negative 4 for y, and we see what happens. Well, this ends up being 3 plus 12, which is 15. But 15 is not less than 15. So what I just showed there is that that one of the points on the line isn't actually a solution. So that's how I would know. How we show that in the picture is we use the dashed line. Question 10, I think our last one. A store sells notepads in packages of 24 and packages of 6. The organizers of a conference need to prepare at least 200 notepads for the event. Would they have enough notepads if they brought these quantities? 7 packages of 24 and 1 package of 6. So let's go here. Here, you're just going to do 24 times 7, which is 168, if I'm doing my mental math correctly here. And 1 package of 6, so 1 times 6, which is 6. Add those together, 168 plus 6 is 174. And so we need 200 notepads, so the answer there would be no. How about 5 packages of 24 and 15 packages of 6? So 24 times 5 is 120. 15 packages of 6. 15 times 6 is 90. Add those together. We get 210, so the answer there is yes. Write an inequality to represent the relationship between the number of large and small packages of notepads and the number of notepads needed for the event. So I'm going to say that the small packages, I'll use S, and large packages, I'll use L. And so the inequality would be 24L plus 6S needs to be greater than or equal to 200. In part C, use graphing technology to graph the solution set to this inequality. Then use the graph to name two other possible combinations of large and small packages of notepads that will meet the number for this event. I don't have graphing technology handy here, so I'm just going to do a quick sketch. I would probably, let's just do it like here. I'm only worried about the positives, and I'm going to put the large packages here, the small packages here. And you could have done it the other way around. It doesn't matter which one you put on which axis. And I'm just going to find the intercepts to graph it. You could also put it in slope-intercept form. But here, if I make s equal to 0, then the L is going to be, end up being 24L has to equal 200. So then solve for L by dividing by 24. What's that going to be? That's not going to be a nice whole number, is it? Well, we could simplify a little bit. 112, 56, 25, 3. So that's going to end up being 8 and 1/3. So 0 small packages, I would need 8 and 1/3 large packages. If I go the other way around, so that means that 6s is going to have to equal 200. That this is when L is equal to 0. Divide by 6. So s is going to have to equal whatever 200 divided by 6 is, which is 100 over 3, which is 33 and 1/3. This graph is definitely not drawn to scale, and that's okay. And so I'm going to make my line, and I want it to be greater than or equal to 200, so I'm going to use a solid line. And I want it to be more than 200, so that's going to be everything that's out here. So if you picked, I'm not going to choose 2 points, but any 2 points, I'll pick 2 out that would fall into this region. I could do, I don't know, 9 and, I could just do 9 and 0, like 9 large packages. That would be, let me switch colors here. 9, 0 would be like right here. That's in the shaded region. Or I could do, let's do 9 and 10. That would be like somewhere up in here. That would be in the shaded region. But pretty much anything that's up there is going to work.